This is a GE Electrek, an electric lawnmower made by General Electric in the early 70s. GE made a whole lineup of electric garden tractors in the early 70s, everything from grass-cutting toilet seat all the way up to play-sized farm implement. And they made an entire lineup of electrically powered accessories and attachments. Everything from an electric chainsaw to a snowblower to a tiller to this absolutely wild thing I have right here, all powered by the batteries in the mower. Before this video, you probably didn't even know these existed, or that there were even electric mowers in the 70s at all. But after this video, you're gonna want one. This is the mower I have, the model name of which is also the answer to the question, what happened to all the cookies? E ate them. The E8M is not the smallest tractor in the lineup. That honor goes to the grass-cutting toilet seat, the ER8-36, seen here next to a strong denim enthusiast. But it is the smallest garden tractor style mower in the lineup. It's missing quite a few features from the larger models, and it has easily the worst speed control setup of the whole lineup, but more on that later. All Electrek mowers were 36 volt and powered by deep cycle lead acid batteries. The bigger models had 6 6-volt batteries, but little ones like this had 3 12-volt batteries. And no, I haven't converted this to lithium yet. That comes later, if it happens at all. Stated mowing range of the E8M was acclaimed up to 3/4 of an acre's worth of mowing. Not very much, but this is the baby of the lineup. If that wasn't enough range for you, and it probably wasn't, then you could opt for the bigger, heavy-duty E8HM, which was exactly the same as the E8M, but with 3 extra batteries under the seat. This version, with extra lead in its butt, can mow up to a claimed 2 acres worth of yard. And you can see under the seat of mine is a big wide open space what to stuff more batteries in. As you might be able to imagine, with the entire length of this mower being a battery tray, it's not the easiest thing in the world to mount. And it's not the most comfortable either. I bought this mower from Kyle, the same guy I bought my Think City from and who generously swapped batteries with me. This was his actual mower that he used to actually mow his yard right up until he replaced it with a cheap Ryobi that he found. He sold this to me for just 250 bucks, and let me tell you, this is the best 250 bucks I've ever spent. This thing's a riot, and it doesn't make any sense. I'm going like 2 miles an hour. It shouldn't be any fun at all. And it's a lawnmower, but it is. It is fun. It's not in perfect shape, but it's not in terrible shape either. It's just kind of okay, which is perfect because it means I don't have to worry about using it. When I got this thing, it was pretty well sorted, but the mower blades were wildly out of balance, so I did something about that. I pulled off the deck motor so I can spin it with the power supply. This is one of the blades that came off the mower. Because there's no way to center it, it was incredibly off balance. So I went on Amazon to order the first blades that were the same length, which was this, and then I 3D printed a spacer to center it. The problem with this blade is it's too thick, which means it's too heavy, and it's too high lift, so it draws far too much power just to spin the blade. So I did some more digging and found this blade and also this blade, which are both thinner, lighter, and much lower lift. I also 3D printed spacers for these, and the blade that I went with was determined by which one drew less power. This blade only drew 8.2 amp, pegged at 31 volts, so I'm going with this one. It's meant for a Black & Decker electric mower of some kind. I don't really care. Now, I really shouldn't be as surprised by this as I am because these are low-lift mower blades, but these are so quiet. This is so quiet. I think this is quieter than my modern Ryobi mower. And they cut fine. Now, unfortunately, the new blades that I got are just a tiny bit shorter than the old blades. So, unfortunately, when I turn right, it does leave a strip in the middle. So I'll have to find new blades, but these work for now. I also gave it some new lead acid batteries that I found for dirt cheap and installed this little current sensor so I can see how much power it draws for if and when I lithium swap it. The rear tires on this have been replaced, but the front tires are original from the 70s. They're incredibly cracked, and I have no idea how they're still holding air, but they are. And the reason the front tires have not been replaced is because they're GE Electrek branded tires. How cool is that? So as long as they're still holding air, and they mostly still are, they're not getting replaced. I mentioned that the E8M is the baby of the lineup. It's missing quite a few features of the bigger models, and the way you modulate speed on it is completely different and much worse than every other model in the lineup. Well, after I exposed myself to this advertising, and that whole promotional film from the 70s that I'll leave a link to in the description below so you can watch the whole thing.
The high peaking power of the Electrac motor easily provides the power needed for hauling and pushing in a wide variety of applications.
I saw all the things that my mower can't do, and I thought, I gotta get one of these bigger models. If only I could find one of these bigger models for sale somewhere in the US, I'd drop everything to go. I drove all the way to Maine to get this. As a reminder, I live in Missouri. This is an E15 model Electrac, one step down from the top of the line E20. It's not in perfect shape, but it looks like it is on camera, so forget I said that. All 4 tires on this one are the original Electrac branded tires, and even more so than the other mower, these have more cracks than a person made entirely of butts, and I have no idea how they're holding air. But as long as they do, they ain't getting replaced. But the real kicker about this mower is who I bought it from. I bought it from the grandson of the original owner, who was an engineer at General Electric who worked on the Electrac lineup in Schenectady, New York. It also came with a full service manual and a very cool attachment that we'll talk about later. This video is sponsored by Factor, ready to heat meals delivered straight to your door. Now let's take a closer look at this vintage GE Electrac ad while I tell you more about Factor. Got a microwave perched precariously on top of a Coda battery pack? Perfect place to cook your Factor meal. This isn't just dumb marketing, they are fun. Factor's ready to heat meals delivered straight to your door. All you do is pick your meal, in this case beef stroganoff burger, and pop it in the microwave for the amount of time specified on the box. In this case it was 4 minutes. 4 minutes away from delightful beef stroganoff comfort food. This is one of my favorite meals from them. Factor's great for if you're tired of meal planning, or you're tired of takeout, or you want to eat healthier than takeout, or you're the type of person that gets really involved in what they're doing and forgets to eat. It's nice to have food ready to go in the fridge. You just pop it in the microwave and eat something. Factor's also good for eating healthier. See this right here? This is delicious portion control. If you want to try out Factor for yourself, and I highly recommend it, it's delicious. Go to Factor75.com and use code AgingWheelsFB50 at checkout for 50% off your first box, plus free breakfast for a year. Again, that's Factor75.com and use code AgingWheelsFB50 at checkout for 50% off your first box, plus free breakfast for a year. And thanks again to Factor for sponsoring this video and this delicious meal. As for why I sought out another GE Electrac when I already had one, well, let me just show you the many differences between these two models. They're about as similar as cake and pie. The E8M has 3 small 12-volt batteries in series and a claimed mowing range of up to 3/4 of an acre. The E15 has 6 very large 6-volt batteries in series and a claimed mowing range of up to 3 acres. Although you can increase the battery capacity on both of these, upgrade to the E8HM and your claimed mowing range goes up to 2 acres, and then you can get a booster pack that mounts on the back of your E15 and claimed mowing range goes up to 5 acres. This has a side discharge 36-inch width mower deck with 2 deck motors and a lift arm thing for manually raising and lowering it. This one has a front-mounted 42-inch mower deck with 3 motors and a motorized lift that sounds super healthy. There. And this mower deck is rear discharge, like me. Oh, and because this motor deck is mounted on the front with just 2 pivot arms attaching it, you can do this. How cool is that?
The housing stands up straight for easy hosing out or sharpening of the blades.
The E8M doesn't have lights, but the E15 does. The E8M has a top speed of, 3 miles an hour? The E15 could go just a little bit faster. The E8 has this analog voltmeter pretending to be a state of charge gauge. It doesn't work. The E15 has that and a power usage gauge. And they do work. They're not very useful, but they work. The E8M from factory didn't come with any of the outlets to plug in any of the electrically powered GE Electrac accessories and attachments, which is lame, so Kyle added one himself right here. This is the 2-pin twist lock connector for some of the smaller attachments and accessories powered by 36 volts. Again, the E8 did not come with this from the factory. Kyle installed this port. The E15 did come with the ports for the electrically powered attachments and accessories. all three of them. There's the 2-pin twist lock connector as seen on the other mower. There's this 2-pin connector here that's actually 12 volts. And then there's this much larger 36 volt 3-pin connector on this side that the mower is currently plugged into. Why are there 3 pins and 3 wires going to a connection that should only need a positive and a negative? It's not the reason you're thinking. We'll come back to that later. You probably noticed this already, but the body and frame of these two mowers is completely different. I don't think there is a single shared piece between the two of them. And thankfully, because the E15 has this nice cutout in the middle, it's much easier to get on and off of, and it's quite a bit more comfortable. Although I gotta admit, because of this cutout and the shortness of the frame, this one's quite a bit less torsionally rigid than the E8. In fact, it's almost floppy. And then we get to the biggest differentiator between these two: how you drive them. The way you control the speed on these two mowers is so different, you would think they were designed by different companies. I want you to think about the time period these mowers were built. Specifically, they were designed in the late 60s and built from 70 to 74. There's two things relevant to these mowers that definitely existed in that time period, but weren't nearly as cheap, refined, or abundant as they are today. And those two things are plastics and electronics. All the body panels that on a modern mower would be plastic, on these two are steel. That includes the hood, the fake grille, the fenders, all of it. The E15 even incorporates a surprising amount of wood. Under the seat is some factory plywood. Even the rollers on the mower deck are wood. Look at this. You wouldn't see this on a modern mower, and I'm not entirely sure that's a bad thing. But much more interesting than the lack of plastics in these mowers is the lack of electronics. Because they're electric mowers. Building electric mowers with limited access to electronics is like starting a bakery with limited access to yeast. Let's start with the charger. A modern charger will be able to sense the voltage, change charge rate at different states of charge, and stop charging once the batteries are full. The charger in these is as dumb as it gets. The charger in this consists of a big transformer, an equally big AC capacitor, 2 fairly large diodes, and a big heatsink, all mounted to plywood. And that's it. That's all there is. Very simple, but if that's all there is to it, how does it know when to stop charging? It doesn't. You may have noticed this enormous knob on the dash of the E8M. This is the timer knob for the charger. You have to guess how long it's going to take to charge the batteries and set the knob accordingly, and it's labeled in letters. How long do you think it'll take to charge the mower today? Well, we didn't use it for very long, so probably C. Now the E15's timer knob, which is under the hood, is labeled with numbers, but the unit for those numbers is years? What's that supposed to be short for? Now the marketing claims that it's impossible to overcharge the batteries, which, sure, but I imagine it's exceedingly possible to undercharge them. And no, I don't use the original charger in either one of these mowers. I use this thing that I bought off Amazon. It's infinitely better, and I don't have to guess how long it's going to take to charge the batteries. The original charger in this one does still work, but I used it once, and after a couple hours it smelled like fire, so I'm not going to use that again. And finally, how do you drive the motors with little to no electronics? This is a modern brushless motor, specifically a 3-phase AC motor from a washing machine. Basically every modern everything, aside from the most basic of power tools and the odd golf cart or forklift, uses a brushless AC or DC motor. You don't need to know how this or any other type of brushless motor works, but know this. If I plug a battery directly into this, nothing will happen. To power a brushless motor like this one from a battery, you need something like this. An inverter speed controller that will take the direct current from the battery and generate a rotating magnetic field to make the motor do spin-spin. A speed controller like this, with all of its electronics and beep boops inside, is dirt cheap and readily available today, but in 1969? No, this would have been completely infeasible. To give you an idea of how infeasible this was, the Apple I, which was just a bare circuit board with no enclosure, launched in 1976, and when it launched, it cost just $30 less than this entire mower. The solution, of course, is to use a brushed DC motor like this guy. If I plug this directly into a battery, it just spins because the rotating magnetic field in this is generated mechanically using brushes and a commutator. So if I just want it to spin at full speed, absolutely no electronics are required. So with attachments like this mower deck, you just flip a switch, the deck motors get connected to the battery, and they just start spinning. But what about the drive motor? That can't just be an on-off switch. One way you can vary speed on a brushed DC motor like this one is by varying the voltage going into it, but that's pretty hard to do without fancy electronics. So how did they vary the speed of the drive motor without something like this? Well, in the case of the E8M and the E10M, they didn't. The drive motor in the E8M and the E10M is not variable speed. It's just on or it's off. That's it. Here's how it works. You've got this pedal over here, which is both your brake and your clutch. You've got a 3-speed gearbox here, so you've got low, drive 1, drive 2, and reverse. There is no throttle, and the rest of the controls are key, and then this switch turns your mower deck on and off. That's right, there is an electric vehicle with a gated manual transmission. And it's a lawnmower from the 70s. To do the forward, clutch in, turn the key on. The drive motor just starts spinning. Let's pick a forward gear. Let's go with drive 2. So we'll go with drive 2, release the clutch, and I killed it. The motor has some sort of overcurrent protection, so you can absolutely stall it. So let's put the clutch in, drive motor starts back up. Let's put it in a lower gear. Let's go with low, release the clutch, and we're moving. And yes, you can absolutely shift on the go. Woohoo! What they've done here is they've made an electric vehicle difficult and confusing to drive. And boy, let me tell you, this is easy to stall. Because this is the only E8M I've ever experienced, it's entirely possible that there's something wrong with mine and they don't normally stall this easily. And if you're wondering why I don't just slip the clutch more, it's because it's not actually a clutch, it's a belt tensioner. But like I said, it's only the E8M and the E10M that are like this. Mercifully, the E15 is completely different. First off, there is no clutch pedal. You only have a brake pedal. And it's out of adjustment, so at the moment, that's not even that. We've got a 4-speed gearbox down here. We've got low, 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 drive 1, and drive 2. There is no reverse. Put that back into low. There we go, a little bit difficult to manage. And this one does have a variable speed motor, and this is your throttle for it, but it is not an infinitely variable speed motor. There are 3 speeds forward and 3 speeds in reverse. And to prevent you from going full throttle, sending all the power at once to the motor and burning it out, it will step through each speed sequentially with a time delay in between. So to see how that works, let's turn it on, return to neutral. It's in low, full speed. You can hear the clicks between each speed delay, and it does the same thing in reverse. Made a liar out of me. There we go. That's full speed in reverse. And of course, there's 3 other gears to choose from. That's how you drive the E15. And yes, it's doing all of this motor speed control with almost no electronics. How? The spinny bit in the middle of the drive motor in the Electrac is not a permanent magnet, it's an electromagnet, the coils of which are called the armature. In speed 3, full speed, full battery power is just sent to the armature. In speed 2, battery power to the armature is sent through a big resistor coil, which resists current flow going into the armature and therefore reduces the power and speed of the motor. And in speed 1, power is sent through 2 of those resistor coils, which reduces it even further. And when I say resistor coils, this is what I'm talking about. These wide metal bands wrapping around this block of... I hope that's not asbestos. This setup is brilliantly simple, but also grossly inefficient. In the first 2 speeds, you're sending a bunch of energy through resistor coils, which is just burning off energy as heat. But how is it handling the time delay between the speeds? Say hello to all of the electronic components in the Electrac E15. No microcontrollers here. You've got resistors, diodes, capacitors, and a total of 6 transistors for the whole mower. The time delays are controlled by these 3 analog time delay circuits here, one for each motor speed, that use a capacitor for the time delay and a transistor as a switch. I'm oversimplifying because I don't fully understand how this works, but for those of you who do understand this sort of thing, well, here's the schematic. By the way, when I first popped this open, I looked at this and thought, wow, they really paid attention to making this serviceable. And then I realized, oh wait, no, never mind. Almost all of these wires are the same color. But hang on a minute. In looking through this service manual, I discovered something. The E15 isn't a 3-speed, it's a 7-speed. So I cracked open the control panel to see what happened to my other 4 speeds. Well, I decided to have a curious poke around behind this panel, and I'm glad I did. Because, well, that's not supposed to be there. Also, this is loose. I don't know if that's a problem, but I'm going to fix it anyway. And then this little thing on top is also loose. This resistor is soldered back into place poorly, and I replaced this terminal in because I broke it. And it's attached now. And after that minor adjustment, my mower goes a lot faster now. Let's just put it full speed. And then, off she go! 4 extra speeds unlocked! I fixed it! So how is it doing these top 4 speeds? Well, the first 3 speeds control the windings of the armature, the windings on the spinny bit in the middle of the motor, the rotor. The 4 speeds above that are controlling the field winding, which is the windings on the stationary outside of the motor, the stator. And this is where I stop fully understanding what's going on here, because in the first 3 speeds, as you add resistors to the current flow going into the armature, the motor slows down. But in the top 4 speeds, as you add resistors to the current flow going into the field winding, the motor speeds up. As you add resistors, the motor speeds up. This is due to something called field weakening, which I don't fully understand, so here's an electrical engineer to explain it.
As Robert explained earlier, the motor in the mower is a separately excited motor, which means we have control of both the stator voltage and the rotor voltage. So what is field weakening then? Field weakening in a DC motor is the intentional under-excitation of the field winding. In this case, for the mower, that's the stator. This is achieved by increasing the effective field resistance to attenuate the magnetomotive force and thus the air gap flux linkage. Since the induced counter-electromotive force must balance the applied voltage, 36 volts in the mower, a reduction in flux means we need a proportional rise in angular velocity to maintain voltage equilibrium. This balance effectively extends the motor's operational speed range beyond its base speed limit, changing the electromechanical coupling constant and altering the system's speed-torque characteristic from constant torque to constant power behavior. This is all very easy and straightforward to understand, so I'm going to assume you got all that, right, Robert?
Yeah, of course I understood that explanation. Any idiot could understand an explanation is, what? Anyway, there is no time delay between the top 4 speeds, but it will lock you out of the top 3 speeds in high current situations like climbing a hill or whatever. The resistors for the field weakening circuit aren't giant metal bands, they're just these guys right here. And this switch disables the field weakening circuit entirely, which is how I was able to fake my mower being a 3-speed earlier. And yes, the astute amongst you may have noticed that I am missing one of these resistors, and whatever was in C1. Speed control was different across the whole lineup. The ER8-36, great name, had a single-speed gearbox, but 5 forward motor speeds and 1 reverse motor speed. And that was controlled by this lever right here. The E8M and E10M, I've already showed you, have a 3-speed gearbox with a clutch and a single-speed motor. Both the E12 and the E14 have 3 forward speeds and 2 reverse speeds, but the E12 has a 3-speed gearbox and the E14 has a 4-speed gearbox. Both the E16 and E20 have 7 forward speeds, 3 reverse speeds, and a 4-speed gearbox, but the E20 is unique in that it has a foot pedal throttle and cruise control. You'll notice the E15 that I have isn't even in this lineup. It's because the E15 is an earlier model that was later replaced by the E14 and E16. I don't know exactly what year this brochure is from, but right on the front cover it mentions the oil crisis. So it couldn't have been any earlier than 1973. This separate attachments brochure I have is from earlier and only mentions the E12, E15, and E20. These mowers are really cool, and the way they work is fascinating, but at the end of the day, they're just mowers. I wouldn't be nearly as excited as I am about them without the attachments and accessories. Sure, there's the normal variety of stuff you'd expect to be offered with a garden tractor. Stuff like a dump cart, a winter cab, a push blade, a single bottom plow, a cultivator, a golf bag holder, etc., etc. But that stuff, that's not the cool stuff. The cool stuff is, this is a drill from the early 70s. Like most every other drill from that time period, it is ergonomically challenged, and the solid aluminum body will suck the heat straight out of your hand on a cold day. This is a pretty basic drill too. The chuck is only 1/4 of an inch, it is not variable speed, and it doesn't even have reverse. So this drill is no good at dismantling. It can only mantle. The reason I'm showing you this, as you probably already guessed, is because this isn't an ordinary drill. It's a GE Electrac drill designed to run off the 36-volt batteries in your GE Electrac mower. Just plug in the 2-pin twist lock connector into your GE Electrac, and you've got a drill wherever your mower is. Okay, yes, I realize that from a modern perspective, this is not impressive, but consider the context. The GE Electrek line was produced from 1969 to 1975, and in that time frame, cordless drills didn't exist. Okay, that's not exactly true. There was an industry-level cordless drill available from Black & Decker, but the first widely available cordless drill didn't come until Makita released theirs in 1978. So cordless drills basically didn't exist. This particular attachment isn't actually referred to as the drill. It's referred to as the power handle because the tool heads are interchangeable. This is a 1/4 inch drill, but you could also get a 3/8 inch drill, a jigsaw, a sander, hedge clippers, and the thing that I have, is this? Plus, GE sold other versions of this power handle that ran off a wall outlet. One was even variable speed. But it wasn't just the drill. GE made a whole lineup of accessories and attachments powered by the batteries in the mower. There was a small tiller, a big tiller, a trimmer, a chainsaw, a snowblower, a shop vacuum, a rotary broom, and an electro-hydraulic front-end loader. They made some proper machinery for these little things, but the two coolest electric-powered attachments, by far, in my opinion, are these two things right here. This is an inverter that took the 36 volts DC out of the mower batteries and turned it into 120 volts AC to power your everything. This took your mower and turned it into a quiet portable power station. You know, like one of these. But in the 70s, early versions of these inverters were actually fully electronic, but also apparently hideously unreliable. So later versions were simple rotary inverters, which is just a brushed DC motor spinning a generator head. Less efficient, but more reliable. And then there's this attachment that I actually have. It's a freaking welder! It's a GE Electrek branded DC stick welder powered by the mower, and it works! Well, it doesn't appear to be a very good welder, but it's the best welding I've ever done with a mower. You know, actually that looks better than I expected it to. Okay, so maybe it's not a great welder, but we'll give it the benefit of the doubt. Assume maybe some connections need cleaning, or maybe it's a skill issue. Regardless, you're gonna love how simple this thing is. In the back is the screw terminal for the positive electrode, and in the front is the negative terminal. You have one for each current setting, low, medium, and high. There are 0 electronics in this welder, so how does it work? Yeah, you remember those resistor coils from the motor speed controller, the big metal bands wrapping around the block of hopefully not asbestos? Well, in this welder box, there's 2 of those. In low, you're sending power through both of those resistor coils. In medium, you're sending power through one of them. And in high, you're bypassing them entirely. In other words, in high, you're just dead shorting the 36 volt batteries in the mower through the welding electrode. That's all this is. Most welders operate in the 20 to 40 volt range, and this mower is 36 volts, so theoretically it's perfect. Unfortunately, the welder and the power head are the only 2 accessories I have for these mowers, unless you count the mower decks themselves. I don't really want to start collecting accessories for these things, but it'd be cool to try something like the snowblower or the tiller. And this feels like as good a time as any to mention the website, myelectrax.com. The guy has a whole collection of Electrax, a whole collection of accessories and attachments, and a bunch of information about everything. And he's got some really rare stuff too, like an industrial version of the Electrac with an electro-hydraulic forklift attachment on the front of it. How cool is that? I'll leave a link in the description. You should really check out that website. There's a whole bunch of information on there. Okay, earlier I gave you a run through of the 3 attachment ports on this mower. Well, it's time to give those a closer look because they are equal parts brilliant and stupid. This is the 12 volt port. I don't know what, if any of the accessories use this port, but here it is. And how do you get 12 volts from a 36 volt pack? Well, you just tap off 2 of the 6 volt batteries and throw the pack out of balance. It's fine. This is the 2-pin twist lock connector. It's just a straight connection to the 36 volt battery. It's always live, which is why this is the port I use for charging. It's also the port used for the smaller, low-powered accessories like the drill, chainsaw, etc. And then there's this connector up here with 3 pins and 3 wires. It's much larger, so it can handle more current for the bigger stuff, like the mower deck, the tiller, the snowblower, the welder. This port is not always active. You have to turn it on with the PTO switch on the dash. And because it powers various deadly spinny things like the mower and the tiller, it's also connected to various safety switches on the mower too, like the safety switch under the seat. You have to be sitting on the mower to activate this port, which makes perfect sense. Except the welder uses that port. So to use the welder, you have to be sitting in the seat? I'm going to assume I'm missing something, because otherwise that's a big oversight. Although this makes me think I'm not missing anything. Leaving the seat will shut down tractor and PTO. Now you might think, well, just disable the safety switch under the seat then. You don't need that. Absolutely not. With this safety switch disabled or pressed down, it is trivially easy to accidentally bump the speed control lever on the mower and send it careening off into my garage door or whatever. Or even worse. Yeah, you get the idea. I'm not disabling the safety switch. So if I want to use that port while not sitting on the welder, I just put this little clamp on the switch. And it works. There's something super dangerous and stupid about these attachment ports that you may have already noticed. But first, another clever thing. Why does the big attachment port have 3 pins and 3 wires going to it when it should only need a positive and a negative for a DC connection? When the PTO is switched on and this port is active, this is the positive, this is the negative, and this pin is connected to nothing. When the PTO is switched off, the negative is disconnected from the battery pack, the positive is still connected, and then this wire becomes connected to this wire. So these 2 pins are shorted together. With the brushed DC motors on this mower deck, I can spin them freely. And yes, it's generating a small current and spinning the other blades. But, and I can't explain why this happens, if I connect the positive and negative of the stator together, that's the stationary bit of the motor, it doesn't spin as freely anymore. It essentially acts as a brake, and you'll notice it's not spinning the other blades anymore either. With the mower deck and presumably other spinny death attachments, the positive is connected to this pin, but the negative is connected to this pin and this pin. So when you switch the PTO off and these 2 pins are shorted together, it's shorted together the positive and negative of the motors on the mower deck and bringing them to a stop basically instantly. And this is super effective. As a demonstration of this, first I'll just unplug it so those 2 pins will not be shorted. They take quite a long time to spin down. And now I'll just switch it off like normal so those 2 pins will be shorted. Stops instantly. That's pretty clever. Okay, now back to something stupid. The 2-pin twist lock and the bigger 3-pin connector for the attachment ports are standardized connectors, meant for 240 volts AC. The power cord for the mower deck is literally a power cord you can buy for an oven at Home Depot or whatever. From a repairability standpoint, this is fantastic. In fact, the 3-pin port on my mower came broken, but all I had to do was go to Home Depot and buy a new one. But from a safety perspective, this is horrifying. Now, it's highly unlikely someone's going to drag their whole mower deck into their kitchen and then plug this into the outlet mitt for their oven or whatever. But you can absolutely do that with the welder. This thing's super portable. In fact, you might already have an outlet like this installed in your garage for a welder. The only thing preventing you from plugging in this welder that's meant for 36 volts DC into an outlet that's going to put out 240 volts AC is a sticker on the back that tells you you might die if you do that. Same goes with every other attachment that uses these ports. You can physically plug this into a 240 volt wall outlet and you might not die, but the tool is absolutely going to. You know what I haven't told you yet? What these are actually like to use. Like, as mowers. Well, they're fine. They're all right. This little guy is just a touch annoying. It's fine when you're mowing at a steady speed, but anytime you need to come to a stop, you just don't want to because it's so hard to get going again. Come on, slip. Yeah, it's on a slight uphill, there we go. It mows fine, and it's a lot quieter than almost any other mower, as evidenced by you being able to hear me while I'm mowing, but that part's annoying. It's probably no worse than any other gas-powered lawnmower from the 70s, especially since hydrostatic drives weren't really a thing yet around this time period, but it is annoying. Oh, and as I mentioned earlier, It's unreasonably fun. This thing's a hoot, and I still don't understand it. The big guy is not quite as quiet as the little one, especially when you get the mower deck going. But it's significantly less annoying to drive than Shifty McStallface over there. The built-in throttle delay takes some getting used to, but at least it starts from a stop instantly. It's just the getting to going faster that has the delay built in. You get used to it pretty quickly. As far as actual mowing goes, when I first saw this front-mounted mower deck, I thought it would be so much better. It's rolling over the ground independent of the mower, so it should cut more level. It's easy to flip up to work on it. It's easy to remove, etc., etc. And all of that is true, but what I didn't see is this. Because that mower is way out up in front, if I want to mow around something, pretend that's a tree, well, I can't get anywhere near it. I have to stop, back up quite a lot, and attack it again. And then if I want to do the other side, well, I got to do that all over again. I can't just drive around something. I have to do this silly maneuvering. And I'm not even getting close to it, really. And not that you'd be doing this with any regularity, but height adjustment on this thing is a pain. You have to unbolt the whole roller assembly on the back, and there's some pins that it bolts into for different heights. And then the front rollers, you have to completely remove them and move washers around. It's a whole faff. So while I love these Electreks, for just getting the yard mode, I prefer my modern electric zero-turn mower, and yes, I realize how completely unfair of a comparison that is to make. But compared to other mowers from the era, it seems like these were quite a bit better. They're dramatically quieter, they're cheaper to run, they require less maintenance, they're easier to drive. With the exception of Shifty McStallface over there, you don't have to go get gas, and you could win a tug of war with one of those inferior John Deere tractors.
The outpull conventional tractors have even higher power ratings, even with extra weight added.
Obviously, you couldn't run a lawn mowing service with one of these. They can only do 1 yard a day, but that's clearly not the market they were targeting. GE built about 30,000 Electreks total. They also built some tractors for New Idea with New Idea branding and paint. But in 1973, they started having some money issues, and in 1974, GE sold off the Electrek lineup to Wheelhorse. Wheelhorse continued producing Electrek tractors in the original Schenectady, New York factory until 1975, which was just a year later. And then they moved production to South Bend, Indiana, where they continued to produce electric tractors until 1983. Some of Wheelhorse's electric tractors were just rebranded, repainted Electrek models, but Wheelhorse did have their own electric tractor models as well. The GE Electrek line was pretty successful, but it didn't last very long at all, and it doesn't seem like it was the smash hit they needed it to be. Economic factors aside, of which there were quite a few around 1973, I think a clue as to why these mowers didn't sell a bit better lies on the front page of this advertisement from 1973 or 1974. Peace and quiet, now starting at $695. That's almost $5,000 in 2025 money, and that's for the base model. And it's only going to go up from there, and then you start adding on attachments and accessories, many of which had their own motor that wouldn't have been I think these were expensive. And of course, they were powered by lead-acid batteries, which kinda suck. And on top of that, GE said you would have to replace the batteries every 5 years, which isn't particularly appealing. These tractors were ahead of their time. Which brings me to my final thought. The solutions they came up with in these mowers to work around the technology available to them at the time is fascinating. But these mowers are undoubtedly compromised by the technology available at the time. If a company today were to build something like this, they could use AC motors with electronic speed controllers for infinitely variable speed control, much higher power and torque, and much greater efficiency. They could use lithium iron phosphate batteries for triple or quadruple the battery capacity and a lifespan of 1 to 2 decades. They could use commodity plastics and electronics to make them a lot cheaper than these were to make, etc., etc. A company today could make something like this, but infinitely better. So why haven't they? Sure, there are several options for electric lawnmowers available today, but almost universally, their battery is barely big enough and they're way too expensive for no reason. Like this John Deere Z380R that is $9,000 and has less battery capacity than the E15 does. And the E15 has lead-acid batteries. But as far as I know, nothing like this, with this size, form factor, and whole range of electrically powered accessories and attachments, exists today, and it absolutely should. Maybe there is a modern spiritual successor to the Electrek lineup that I just don't know about. If there is, let me know about it. What a rabbit hole I went down when I got this one. What started out as, hey, would you be interested in my old mower? Turned into, whoops, I got two of them now. When he arrived with this thing, I didn't really know anything at all about it. And then he showed me the drill and I was instantly hooked. And then I started looking up information about these. I got down a rabbit hole and then I started hunting for the bigger models for sale to buy. And that's how I found this one. And I did drive all the way to Maine to pick it up. And I don't regret any of it. These were great purchases. I don't really know what to do with them now, especially since it's going to be winter soon and they're just taking up space. But I'm glad I have them. They made for, at least I think, a really interesting video. And thank you for watching. I don't know how to end this. I like these things. They're cool.